There are multiple ways to approach an egg drop challenge. Firstly, to establish a few parameters, we will be using uncooked store-bought eggs, and we will be dropping from a height of 10 feet. Before we show some potential designs, let's walk through some of what we considered before approaching this problem. Egg geometry. Eggs are oval. Oval is derived from the Latin word meaning egg. And therefore, eggs have a thinner, what we would label as the top, and a thicker bottom in terms of width. We know from physics that the easiest way to puncture a material with a set force is to strike the material at a direction normal to the plane of interest. In other words, we crack eggs typically by hitting their flat side perpendicular to a blunt or pointed surface. If you increase or decrease this 90-degree angle of impact, you change the normal force to a shear force. The more shear a force is, the more energy will be required to puncture the material. In this case, an eggshell. The same principle applies to a bullet ricocheting off of a wall when it is not fired directly at the wall. With all of this in mind, we could argue that the top of the egg is the most resistant to normal forces, as it has the least likelihood of it striking the ground completely perpendicular due to its overly curved surface. The point, however, does create a pressure point as all of the force is concentrated onto a smaller surface, rather than dispersed over a greater area. Think of how it's easier to break the tip of a sharpened pencil than it is to break the tip of a dull pencil. These points should and will be taken into consideration. So the first technique we will demonstrate is to cushion it with an inflatable bag, much like a car's airbag. Air was collected into the bag, and then the drawstrings were drawn to narrow the opening width. The egg was dropped before the air had enough time to completely exit the bag, and when the egg collided with the bag, the mass of the egg dispersed an equal mass of air from the bag. Since the opening has been cinched, the resistance was enough to decelerate the egg before it collided with the ground, but not too much to cause the egg to bounce off of the bag and onto the ground, which could potentially cause it to break. Another approach could be decelerating the egg with a flexible material that gives slightly and slows with friction. Or you can slow the rate of descent with a wind-catching material stringed to the top of the egg, much like a parachute. This technique shown combines these two approaches and uses a piece of cardboard, plastic trash bag, and tape. The cardboard is bent into a cylindrical shape so that the egg fits snugly inside. The friction between the egg and the cardboard prevents the egg from coming in contact with the ground when the cardboard makes contact with the ground. The plastic bag causes some drag and helps decelerate the entire system as it falls to the ground. A very simple approach you could implement is simply wrapping the egg in bubble wrap. So long as you get enough layers around the egg, it will not crack when it hits the ground. The last model we will show absorbs and disperses the energy of the egg as it collides with a fixed structure on the ground. As you can see, the structure has a wide opening at the top which tapers down to a smaller diameter at the bottom, forming a conical shape. As the egg enters the top of the structure, it is slowed slightly by friction against the straws, but mainly slowed by the straw's ability to flex outward when the egg enters the cone. All the downward force of the egg is transferred to the straws and dispersed outward, preventing cracking of the egg. In the videos shown, improper alignment of the egg before dropping, and also environmental factors such as sticky fingers, prevented a successful experiment. This goes to show that practicality of a design is also very important to consider, and in this case, the other factors needed to conduct a successful attempt make this approach less desirable than the aforementioned ones. While there are many methods we did not mention or demonstrate, we hope this short video was informative and at least somewhat interesting. Feel free to draw inspiration from these designs or create a completely new method that is superior to all others. The only limit on what you can accomplish is the limit you place on your own creativity and work ethic.